about, right? We looked at those 5 number summaries yesterday, and at the very bottom, we started to talk a little bit about our data. We started talking about if there were outliers in our data, if there was a symmetric or a non-symmetric data, right? So we started talking a little bit about actually interpreting what was happening in our data. So on the second page there, we're now going to talk about the shape of our data, where the center of our data is going to be, and something called the spread of our data. So the first one there, the shape of my data, the shape, get my pen. So the shape of my data tells me how my data is distributed, how it's given away. So if it's symmetric or if it's not symmetric data. So the shape tells me how it's distributed. For my first piece of data there, how it's distributed. The center of my data is exactly what it sounds like. The center is going to be located at the middle of my data set. So depending on what my data looks like, I can either use the mean or the median to find the center of my data, right? That average point. So we've got the shape of my data, right? So if it looks kind of like a bell curve, or if it looks like maybe a bell curve that's off to the side. We've got the center of our data right in the middle. And then we've got the spread of my data. So my data tells me if, or the spread tells me if my data is really far apart or if all of my data is really close together. That's the spread. So it tells me how close together, bless you, or how spread apart the data is. Oh, spread apart. So depending in a moment on what the data looks like, we're either going to be using the range, the interquartile range, the mean absolute deviation, or standard deviation. So I'm going to explain what all those mean in a moment. The last part is the peak. So the peak of your data, think about like a bell curve. Peak means it's right at the top, the peak, the top of it. So it's where the data is higher than all the rest. Right, it's your peak. It makes sense, right? Where it's the highest. It can be found by looking at the mode. The mode is the one that is written the most amount of times. So it's your data that repeats the most often. That'll be what's higher. There are different names for how many peaks that you have. So if you have one peak, it is called unimodal. Unimodal. Una means one. So unimodal means it has one peak. So it just is like a regular bell curve. If your data has two peaks, so it goes maybe like peak, peak, like two like humps of a camel, essentially. Two peaks. Yep, it's actually called bimodal. So unimodal is one, bimodal is two. Trimodal. Well, if it was only three, yes. But once we get three and more, we call it multimodal. Multimodal.
Antimodal.
Multimodal.
Unmodal.
You're close. I mean, you kind of got the right idea. If it has no peaks at all, it's just called uniform data. So it just goes straight across, uniform. Everything's the same. You had the right idea. Uniform data. So now we're going to take a look at some of the data below. We're going to look at some examples, and we're going to talk a little bit about the shape, the center, and the spread of the data. So I've got an example there. It says students were surveyed on how many minutes they spend reading each night. So if I look at the x-axis, what is located on the x-axis? Is it students or minutes? Which one's the x?
Miles. I mean minutes.
The minutes. Okay, this one's my x-axis. That's my independent variable. My y-axis is my number of students. So first of all, this graph right here, if we go back to yesterday, what type of graph is this?
It's a bar graph.
Oh,
It's a histogram.
it's a histogram. A histogram. Why is it a histogram, not a bar graph?
But they're touching.
They're touching, and it's talking about the number, the count, or the frequency on the left side, the number of students. So as soon as you see a range and the number of something, you're looking at a histogram. So maybe we write that at the top. This is a histogram. So first one says, how would you describe the shape of the data? So that tells me if it's distributed or not. Yes, Jada. You're right. What do you think it is? Yeah, a bell curve. Exactly. So a bell curve is also just called symmetric. It's the same on the left and the right. So a bell curve is called symmetric. Good. So we'll say a bell curve / symmetric, whatever you want to call it. Good. Second one. How many peaks does the data have? Hudson, what do you think?
One.
It's got one peak. What is that called if it's got one peak?
Unimodal.
Unimodal. This is unimodal. Now, estimate the center or the mean or the median of this data set. So looking at this picture, where's most of my data located? In which section? 15 through 19 right here. There's where most of my data is located, in the 15 to 19. Now, how would I figure out what number is right in the center of that? You can count, or, Colin, you were saying it? Add them and divide by 2. Good. So between 15 and 19,
17.
It's 17. It's easy to kind of tell, right, to count. But you could also take 15 plus 19 and divide it by 2. $15 plus 19 anyway gives you 34. And if you divide that by 2, it's approximately 17. So that right there that we just did, which one was that? The mean or the median? Which one was that?
Well,
When you add and divide by 2. That was the mean. And the median is the one that's right in the center that we can just count to. Or sorry, the median. The median is also 17. So the center of my data is at what?
17.
About 17 what?
Students.
Minutes. 17 minutes. So my center is 17 minutes. Okay, last one. How would you describe the spread of the data?
Large.
What do you mean large?
Huh? Spread apart.
Right, so are they close together or are they spread apart? So we find it by looking at the range. What's the range of my data?
6.
So what's the smallest number I have?
6. 1. 0.
0 number of minutes. What's the largest number that I have?
34.
34 minutes.
Oh my God.
You're looking the wrong way. So you're looking at the number of students that I interviewed. That's okay. I'm trying to look at the number of minutes. So my data is spread out from 0 to 34 minutes. Zero to 34 minutes. I would say that that's pretty spread out, right? From 0 to 34. That's a pretty big, pretty wide distance. But again, it makes some symmetric data. So it's spread out in even amounts. Spread out in even amounts. Or in even intervals. So anytime it looks like a really nice bell, that means that your data is spread out really in even intervals. So it's spread out really nicely, really symmetrically, right? If I put a line down the center, whatever's happening on the left is pretty much happening on the right. That means you have a very symmetric data spread. Okay. All right, flip it to the next page. Now,
Oh,
on the next page there, it says, data sets at the very top. Data sets can be categorized by how they are shaped. How they're shaped. Yes, they're all essentially roller coasters. All of them. But there are different ways that the data can be distributed. So we've been looking at this center one right here. Right? That's what all of our data has been looking like before. A really nice looking bell curve. If you have data that looks like this, the mean, the median, and the mode are all at the same point. It's all right at the center. So it makes your life really easy. There is also something called left and right skewed distribution. So if it is skewed, that just means more of the data is pushed to one side. So you have more like number of students over here, and on this side you would have like a smaller amount of minutes over here, right? So it's just which way that the graph is pushed. Now be really careful, most people get this wrong. A left skewed distribution means that most of your data or the hump of your data is on the right. A right skewed distribution means that most of your data is on the left.
So it's based off of the...
It's essentially based off of, yes, the curve, the longer line. It's not based on the hump, it's based on where the curve is. Good. And then there's just some different images for you there, right? So here's what a graph would look like if it was left skewed. Here's what a graph would look like if it was right skewed. And then I've got some different images over here for you. Now, the last part is this little section down here. It's a little chart for you as we go to answer our questions. All right, I'm going to ask you guys to stop talking one more time and then I'm done. Down at the bottom, it says, is the data distribution symmetric? So here's what you're going to do. I've got a little flow chart here, and it talks about the center and the spread of your data. Now, depending on where your data is located, you are either going to use the mean, the average, to describe the center, or you're going to use the median to describe the center. And that's two different things. Two different things. And so that is based on if your distribution is symmetric or not symmetric. So if you have a symmetric graph, a graph that looks like a bell curve, yes, you would use the mean or the average to describe the center. You would use something called the standard deviation to describe the spread of your data from the smallest to the largest. That just means how far away your values deviate or go away from the mean. And I'll show you what this means in a second. If your data is not symmetric, it's not symmetric. So it looks like one of these ones where the hump is to one of the sides, the peak is to one of the sides. Then you are going to use the median to describe the center, and you're going to use the interquartile range to describe the spread, which is something that we've looked at before. So we're going to use that little flow chart to help us answer the questions on the back side. So let's take a look at the next one. We're going to be flipping back and forth. Okay. Just so you're aware, we are going to be flipping back and forth. So here's my first graph. In graph one, we're going to ignore everything down here. We're just looking at the top. There are two different graphs or two different distributions on the same graph. So we're going to start by looking just at the shapes of the two distributions, the shapes of them. So if you look at distribution A, right over here, here's distribution A. To describe the shape, I'm going to come back over here, right, the shape of my graph, I want to know, is it left skewed, is it symmetric, or is it right skewed? So if you're looking at this first graph, graph A, just this top one, is that symmetric or is that graph not symmetric?
It's a bell curve.
Good, it's a bell curve. So A is symmetric. So I'm just going to put A is symmetric. Get someone let whoever's there in, please. A is symmetric. Okay, I'm gonna do this in 2 different colors so that it's easy to see. So here's A. Now, here is distribution B, right here. If you're looking at distribution B, is that one symmetric or is that one skewed to the left or right? That one is also symmetric. Good, so we're gonna write down that B is also symmetric, right underneath it. Mm-hmm. Okay, both of those are symmetric. Super easy to see, right? So far, so good. Yes.
Do you want us to put color on it, or are you just doing that though?
Say that again.
Do you want us to use colors too?
It's up to you. If you have colors, you can. I think I have some. If you guys want me to grab out some markers, if you want to borrow some, I can do that for you. I like colors. I'm a visual person, but it's up to you guys. Do you guys want some markers? Okay. Yeah, no, I'm just doing it because it's hard to see up on the screen. Okay. Now, letter B. Which measure of center would best describe the data? So let's look back at just distribution A again. So back at just the pink one. To figure out how to describe the center, I'm going to flip to the back, flip back over where I was, and I'm going to come down here to my little chart. If you looked at that graph A, was your graph symmetric or not symmetric?
It was symmetric.
It was symmetric. So what are you going to use to describe the center of your data?
The mean.
You're going to use the mean. You're going to use the average. Okay. So for A, we're going to use the mean because it's symmetric, right? So we're going to use the mean for the center. Okay. What about graph B? Why the same thing? Because it's what? It's also symmetric. Good. It's just lower down, but it's also a symmetric graph. So to describe the center of your data, the middle part of your data, you're going to look for the mean or the average. Okay. Now it says, how do the centers of these 2 distributions compare? Okay, so I've got distribution A in pink. Blue is down over there underneath it. Now, to find the center, right, we just said we're going to look for the mean. The mean is located right at the center of where your hump of the graph is, where the top of your graph is. So if you look at the pink one, if you go to the center of your pink graph right here, okay, center of your pink graph right over here, you go over 7, what is your, how many of the 7s do you have? What's your frequency on the left? You've got 10 of them. Good. What about for the blue one? How many do you have? You've got 6. So your center for distribution A should be, right, it's bigger than your center over here for distribution B, right? So you've got more of this one than you do of this blue one over here. Now, what do they both go to, though, on the x-axis? They both go to 7 over here. So their center line, while this one has more, it's got a bigger frequency, their center is at the same place. They both go over 7. So my center for graph A, my center is over here at 7. So that means the mean or the average is 7. What would be the mean or the average of the distribution B in blue? It's 7 again. It's the exact same thing. My center is at 7. So my average is 7. So how do those two centers compare? What do you notice about the two of them? They're what? They're the same. They're equal to each other. So the comparison is they're equal. They're the same. Equal or the same. Now, last part we're going to do is the spread of this data, and then you guys are going to try the second graph. Okay, now we're going to look at the spread of the data, the spread. Spread means where do you start, where do you end, and how far does that go on the x-axis? How much space do you have between the two? So if we just look at the pink one right here, the pink one starts at what? 2, and it goes all the way to what? 12. So in total, what is that spread?
10.
From 2 to 12. That is 10 places. Good. So your spread for letter A is 12 minus 2, which is 10. What is your spread for B?
2 and 4.
So where does the blue graph start? On the x-axis. 0. Where does it go all the way to?
14.
14. So what is your spread for graph B? How many spaces does that get from 0 to 14?
14.
It's 14. So which one of yours has a greater spread? Greater spread of data, graph A or graph B? Good. So I'm going to put up above, right over here, where I have a little more space, talks about the shape. I'm going to write that the spread of graph B is greater than the spread of graph A. Right, so this one in blue, it's got a wider graph, so the spread is longer. So a larger, like, flatter hump. Okay, I would like you to do number 2 right now. Exactly the same thing, number 2. So you're going to talk about, are these symmetric? Are you going to use the mean or the median? And then you're going to look at those graphs and look at their spreads. So talk to people at your table, try number 2.